Team, I request you to start the recording, please.
Thank you, Dr. Sudhanshu. It is a pleasure being a part of this grand event at Amity University in Tashkent. And I welcome all the dignitaries before I formally start the session. Uh, we are at the third edition of the International Conference on Technological Advancements in Computer Science, organized by Amity University in Tashkent in technical partnership with the IEEE Kazakhstan subsection. This event has been very achieving and absorbing for the last 2 days, and today is the culmination of the event. We have had experts and brilliant minds from all around the world coming up with brilliant ideas of research, inspiring each other, and helping shape future better for the society. More than 800 papers were received by the university, and out of that, as a team, 223 were selected post rigorous review procedures. We're honored to have you all with us today as we embark on this journey of knowledge, innovation, and collaboration. This conference has been serving as a platform for experts, researchers, and professionals to discuss breakthroughs, share experiences, and foster meaningful connections. This keynote session is another add on to the glory of the event. The first guest for the keynote session for the day is Dr. Manoj Kumar, Associate Professor, Cybersecurity Research Club, Head Network and Cybersecurity, University of Wollongong, Dubai. Sir, we are honored to have you with us and we warmly welcome you for the same.
Thank you
Dr.
very much,
Manoj completed his PhD from North Cap University and MSc from Technological University, Dublin, Ireland in 2013. Sir has received fully funded scholarship for MTech and MSc program from Irish government and MHRD respectively. Dr. Kumar has more than 13 plus years of research, teaching, and corporate experience. Dr. Kumar is currently working on the post of Associate Professor, Cybersecurity in the University of Wollongong in Dubai. He has published more than 170 articles in international refereed journals and conferences. Sir has over 10 patents on his name. He published 3 authored books and 8 edited books for more famed publishers like Springer, CRC Press, IOP, Taylor and Francis, to name a few. He specializes in digital forensics, machine learning, information security, image processing, IoT, and computer networking. In addition to the above mentioned categories, Dr. Kumar has delivered several guest lectures and presented his ideas and views at seminars. We're proud to have you with us, sir. I know there is much more to your profile, but we welcome you warmly with whatever little I could explain about you as an individual. We welcome you, sir. The platform is all yours to deliver your talk. The topic of discussion which Sir is taking up today is optimization of software reliability allocation problems using genetic algorithms. Thank you so much, sir. Over to you.
Yeah, thank you very much, ma'am. Thank you very much for such a wonderful introduction. And I'm very honored to be part of this conference that you invited me
Mr.
to deliver.
Manoj, sir, Dr. Manoj, sir, am I audible to you?
Yeah, you are audible, ma'am. You are audible. Yes, you are
Dr.
audible.
Manoj,
Yes,
am I
yes.
audible to you for the invitation to take over the platform?
Yes, you are audible, ma'am. Hello.
Sir, please you continue. I think there is some problem.
Oh yes.
Okay.
Yes, sir. Sir,
Yeah,
now
you
I
are
got
audible.
it. I think there was some technical issue at my end. Thank you, sir, for
Yes,
taking
you are
over the
audible.
platform.
Yeah,
All
thank you, ma'am.
yours.
And I think there was a mistake in the keynote title. Anyway, I will share my screen. So it's not about software reliability, but it's about like networking. So let me share my screen and I will play PPT. Is the screen visible, sir?
Yes, sir, visible. Kindly make it full screen.
Yeah. So the title of the talk is like an ensemble framework for the detection of DNS over HTTPS traffic. And I'm very thankful for such a wonderful introduction. And as ma'am said, I'm working as an associate professor in the Department of Computer Science and heading the network and cybersecurity cluster here. And but that's why I chose this particular topic, because we are doing a kind of research in this area, and we already published one article, and it's still going on. We are just trying to make improvements in the DO protocol, and that's why that talk is very special for me, and it has a wide scope as far as the computer network is considered, and and also because security is an important part for us. And without taking any time, because we have very less time to deliver the content, so let's start with the introduction of this specific thing. I mean, DO. So DO is nothing but it's like DNS over HTTPS, and that was already published. I mean, about the basics of this protocol is published in RFC 8484, and there you can get how this DNS server will work, and how it's to be integrated if you have like HTTPS data or HTTPS protocol generated packets. Another thing is that why this one is important for security perspectives, because this helps to avoid the eavesdropping and man in the middle attacks. So whenever a particular attacker is going to steal some of the information using all these DNS queries and all that, right? So in that case, this particular protocol helps us. And these are kind of working where a user has to place a DNS query, and it goes to your your local DNS server if you configure within your like perimeters. Otherwise, and then it's any request goes to the external server, and it asks for certain kind of data or whatever the a particular user asks for query. I mean, the kind of mapping is there, so that mapping is to be done with the help of a DNS basically. And earlier the problem is that the data is to be traveled in the plain text form, and in that case, like this man in the middle is performing or attempting man in the middle attack is very easy, but like it's with the HTTPS implementation, so it's bit like encrypted, but still there are so many loopholes that exist. So what we are trying to do is that we are just trying to analyzing the data, and we are just trying to find the flows, like how you can improve the security in more ways, right? So there are like 6 steps to perform the working of DNS, and I think every student should know like how the DNS server will work, how the query is to be placed, and then server is going to reply with their dedicated that IP address or URLs, right? So it's very important to understand. And then when it comes to how it works, so then as I said, like we have the local network and the external internet implementations. And the local network, we need to make a server that is known as the local DOH server. So that is nothing but the DNS over HTTPS proxy server that we need to configure within the network, so that it brings a kind of layer of security over the data. And then we also have like DOH enabled client, that is just like backend client, you can say, that is configured with the DOH basically. And then all the requests that sends a particular traditional client goes through all these DOH proxy servers, and it travels outside the network and goes to that DOH server, that the main server that integrated with the different type of root servers or TLD servers or SPTD servers or domain authority name servers. So I mean, all those servers are going to be communicate with the DOH server, and from there your DOH client creates a request and sends different request for accessing the content. Another thing here to understand is that like whenever a client is going to put a request there, so there are kind of attacks that is regarding the caching and all that. So caching, or if it's like DNS spoofing, even the DNS spoofing is one of that is a kind of attack that attackers can perform. But certain problems are there. So what are those problems? We need to identify all those problems. Like, if we have implementation of a local DOH or DOH implementation, then like it stops the third party from analyzing the domain name server. So that's the one thing. That's one problem. Then it's also like the traffic for security purposes. So as it's a like use packet is or data is being generated, and then it creates a kind of bring a kind of unsecurity in the data. That we'll try to understand like how this thing will be taken care. And then split the DNS in the enterprise networks. If more networks are there, then you can split the domain name server, and you can create just like the scenario that's shown on the internet side. And then another problem with the CDN localization. So there's nothing but the content distribution network. It should be localized at different places, just like YouTube and Netflix. They have their CDN servers placed all over the world. So, but if that is the case, then I mean that is another challenge that we are facing when we are placing DNS queries on the server. And like in 2018, I think in 2018, Google and this Mozilla, they started the implementation of DOE, DNS over HTTPS, and later in 2020, Firefox decide that okay, we are going with the DOE implementations on their browser. Even we collected data from different browsers, and with respect to like DOE implementation or kind of the packets that have malicious and non-malicious data, and then we did kind of analysis so that we can provide or we can bring some security in there. And these are problem statement. Firstly, since DOE encapsulates the DNS messages within the HTTPS, and that's why the name is DNS over HTTP, as it encapsulates the messages within the HTTPS and works on the HTTPS2 framework. So, or the with that protocol. So it makes the detection of DNS traffic and making the data vulnerable to attackers. So that's the first problem statement. The second problem statement is that the malware can utilize the HTTPS2 connection, yes, for sending the different DOE request without even like creating a different connection. And they can, the attackers can easily bypass various security measures that if you configured or you implemented in your network. So that's the thing that that DOE will be more effective, or you can say like it should be more effective when it comes to the HTTPS2 implementation, and it should be. So that's why what we are doing is that like we are testing this particular DOE data using two different levels. And so that man in the middle attack can be avoided basically. So due to the usage, and next problem is due to the usage of a new DNS resolver and emerging new threats. As we know that cybersecurity is now like very niche area, and attackers are very sophisticated, tools are very sophisticated, and that's why we need to think. For DNS perspective, we also need to think like how we can make the data more secure, or these DNS queries more secure. So in that case, it's another problem that it makes it difficult to detect the DNS tunnels if you create it, and harder to mitigate its associated threats. So that we have the implementation of VPN or like the IPsec implementation, but still like it's very difficult. So that also one problem. Then to overcome and to work with these problems, like the first is like we need to define certain objectives so that we can implement this work and we can start that, and to design an intelligent and efficient and automatic framework for categorizing the two-layered DOE traffic architecture. So that's the first objective of this presented work. So, and we cover like we implemented a few of the objectives, and some of the objectives are still like we are working on that, and we are just automating the solution. So we are just trying to provide real-time solutions to analyze the DOE traffic. Okay, and using machine learning techniques, we are going to classify DOE and no DOE traffic at two levels, level 1 and level 2, where we have different machine learning algorithms, and we are also using the ensemble framework. Okay, so ensemble framework with respect to like we can say like three different machine learning algorithms in one framework, while three in another framework with the ensemble learning. And then reliability and robustness of the proposed method is also be checked by error optimization. We use like different matrices. The quality matrices to check the robustness of this method. The method is compared with the different existing method that was published in 2022 and 2023. And our proposed solution is better than that. So I'll show you a few of the results, and so that you can see like the performance of this particular model. So the database that is being used is from the Canadian Institute of Cybersecurity. So they have like CIRA and CIC Dobiru 2020 dataset, which and the data is divided into different levels. But there, like you can see that the different files are there. So do.csv and non.csv, these are two files, and there are like 115,000 packets or data is there. So it's like a huge data set. It's a huge data set, and it's enough to train your model, enough to understand like how this or this DNS over HTTP is to be or working, or how you can detect the parameters or the features of that. And the data is being captured using different client browser, even though we also captured at our end. So we use this data set, that's one thing, but we also captured certain kind of data by using different browsers. And you can see, and the DOS server is the Edgard Quad 9. Whatever be the cloud browser we used, so we used the Edgard Quad 9 DOS server. And there are like you can see like different packet counts is there, and the data is also, that data or the traffic is also divided into certain types like HTTPS, non-DO, or the benign DO, right? And then we have malicious DO data, and then we did kind of classification or working on that particular data. And this is how this framework will flow. So input is like though HTTPS traffic data. It could be either from the data set or the source that you are using, or you are captured. If you captured some of the DO traffic within your network, then you can also use that data. Just an unknown. So that's why this is important. Like we have the training and testing. With the training, we use kind of the data set, and for testing purposes, we tested the model with our data set as well. And this is, as I said, like, we divided into two levels. So that's where it brings a kind of ensemble learning based, analysis at level 1, and also like ensemble based learning at level 2, where different machine algorithms are to be used, like the regressions and the decision tree models, random forest. Then we have the LGBM. So these are the algorithms with that, this testing has been done. And from the data, we classified, the classification of DO traffic using machine learning technique is done again. It's another layer of evaluation, and then evaluated different machine learning algorithms with respect to their precision, recall, or F1 score. All these parameters are to be used, and then we classified whether that particular traffic is malicious or non-malicious, right? And at the particular point of time, why this is why this classification is to be done at two levels, just to understand, just to implement the model in the real-time framework. And we implemented in the real-time framework in the real time, and it shows a good results of the detection of malicious and non-malicious connections or the queries. So basically, in a more broader way, you can say like there are 3 steps. So in the first steps, it's regarding the data processing, where different features are to be processed from the data, and data is explored, and visualization and imputation is to be done. And there are, like, as I said, like there are more than 110,000 records are there, and out of that, somewhere around 8,500 records are without any values, or like useless records were there. So we removed all those through the imputation techniques, and then we extracted features, and the features that are there are like 34 or 35 features are there. 34, but 35 features are there basically. And the model is trained on those all 35 features, and that's the part of the data modeling where feature normalization and selection is to be done. And that's like packet time variance, packet time standard deviation, and then you can say packet time mean. These type of features to be used at the ensemble learning level 1, and other features like packet time mode, or median, right, or like source and destination of those packets. So that is to be done at another level. And finally, the model is evaluated, and we evaluated using different machine learning techniques. That's one thing. And then also we compared our results with the state of art results, what other researchers did. the past. And this is one of the results, that is the classification of do and known do traffic at level 1. And if you will see, like there are, we use like different, these are the basic the traditional machine learning approaches, and but the proposed one is the EL1 and EL2, so ensemble learning 1 and ensemble learning 2. And if you'll see, the accuracy and the precision recall is like as compared to all these traditional methods, it's more. And this model, believe me, this model is able to produce almost like 99.7, 99.5% accuracy in the detection of known and no-do traffic. And this is another like accuracy of do traffic at 2 levels. So in terms of this one is important for us, because we tested, and if you will see the proposed method as EL1 and the EL2, so it gives accuracy of the do traffic at both the levels, right? At level 1 and level 2, so both are outperforming. So the proposed method is outperforming compared to all these traditional methods. And the accuracy is like at level 1, you can see that accuracy is almost 98, 99%. At level 2, we change a certain kind of parameters, and even there also like the accuracy is like 99%. So at level 2, like accuracy is more in terms of detection of the DNS queries or the things in the do traffic. So basically, the results are very good. Results are impressive, and we implemented this in the real-time framework, but still the work is going on. So still like we are just trying to improve, because it is taking more computational times, and that's another things. We're trying to reduce that. So two ensemble-based learning techniques, EL1 and EL2, that showed superior and the state-of-art results in categorizing the do traffic by achieving an overall accuracy of 99.5 and 99.7%. Even the app score is about 99.8 and 99.7% for both the proposed frameworks. And the proposed ensemble-based technique require computation. That's the thing that we're still working on that, and we are just trying to build or trying to changing the parameters, or trying to improve how this can be minimized in the real-time framework, or in the real-time scenarios when you have real-time data or real-time implementations of that. But due to their accuracy and less clashing error count on the real-time simulated, it makes it ideal for the development in real time. So that we already did that, and it's very good. Like we have very impressive results in discovering the malicious do traffic in the network. So that's the best part of this proposed method. Even though the other state-of-art methods, they computed, they did a kind of analysis only on the the data set that they have, but we tested it in the real-time framework. And that's the that's the first part of this project that we are doing. And another thing is like for students, for as a future work, what they can consider is that that's DNS over HTTP. So our next thinking is that we are going to implement DNS over TLS, because TLS is also to be used for the security purposes. So that's the takeaway. Like with the HTTPS, you can do kind of implementation, but also like you can think like DNS over TLS, that is still like work is going on, but still like not that much effective. And but there is a huge scope if you do work in that direction. And there are certain kind of references, and we also like published that article, and it's available online. So the first part is available online, the second part is still like working, and so now it's not the time to disclose. But the thing is that DNS over HTTPS and DNS over TLS, both can be very helpful to protect your data packets, or to provide security to your data or your queries that going through the DNS, or avoid many in the middle attacks, eavesdropping, DNS spoofing, all that kind of attacks. And that's just a short part of this keynote. I hope you enjoyed it. And if you have any queries, you can ask me. I'm open for the queries as well. Thank you very much.
Okay. So thank you, Manoj sir, to enlighten us and our participants with
My
your
pleasure, sir.
valuable talk on this ensemble framework for detection of DNS over HTTPS DOS traffic. Sir, may I request you to please turn on your camera, so that the participants may have the live interaction with you.
Sure.
Yeah, thank you,
Yeah.
sir. Thank you.
Sir. Yeah.
And even our all the colleagues from the IT department, they are in this uh, keynote session, and there are a lot of questions are there which are available in the chat box, sir.
Sure, sir,
So,
sure.
so I think that you can have the direct access of this from the chat box, and you can
Mhm.
take over these questions. Participants, all of you are requested. If you have any questions, you can put it in the chat box. IT team, our guest Dr. Abu Bakar has joined, and I request you to give him the right.
Okay, how can, I mean, the first question is like, how can DNS tunneling attacks be detected and prevented? So, I mean, very good question. And like, that's what I said in the beginning. I mean, this is one of the challenge. And if you will see this, the problem, this is very challenging. I mean, detecting DNS traffic through tunneling is very tough job. I mean, you need to try with different methods. The first is like, even VPN is implementation of that. So it's a kind of encapsulation. So you need to like design different algorithms or a scenario where you can detect those. I mean the DNS packets. Basically, the thing is that like how it is to be. So if you have implemented, the implementation of HTTPS, right? If you have the implementation of HTTPS or IPsec, then by analyzing the packet, so you have to use certain kind of sniffing tools. So in practical scenario, if you are like if you are not in the implementation side and you just want to try to attack or just want to see like how it is work, then you can use like different spoofing and these spoofing type of tools. Like Wireshark is one of them. I mean, the one very basic where you have a basic understanding and you can understand the protocol from there. So I mean, using that can be done, but it's again like it's a very challenging, but there's the one way, right? So that can be done. Okay. Then what's the next question? Let me check. What's the next question? Yeah, here. Okay. Dynamic selection of ensemble possible in reality? Yes, it is possible, and we did that. I mean, we selected, and it's nothing but it's a kind of learning to your model. So ensemble is nothing. Ensemble learning is based on the parameters that you are applying to that. So it's like more like accurate and more framed. So you can do that. And if you are like, if dynamic selection means like you want to select all the parameters in the like by involvement, then it is not possible. But yes, by automated you can do that. I mean, that's the right thing to do that. And will the DNS or HTTP be encrypted? Yeah, it's in the encrypted form. In that, how ML can be applied over encrypted data. So we are not talking about like putting the machine learning algorithm on the encrypted data. Basically, if you will see, so even the the packet that you capture by any SIM tool or any like the Wireshark, so everything is encrypted. You just see the basic information. Data is still encrypted there, right? So machine learning algorithm is not about to unencrypt the data or for the decryption of the data, but it's about the analysis of the pattern in the data. Okay, so there you can apply machine learning algorithm. We are not performing any machine learning algorithm for the decryption purpose. So that's the one thing. And I think one more question is there. So ensemble uses fixed set of classifiers, or you use different ensemble dynamically based on the type of traffic? Yes, that's based on the type of traffic that we have. As I said, like we have, this is a huge data set that we used, and we used our data set also. And then we picked certain kind of, algorithms that's best suited with respect to our problem. So whatever problem you are, or you are solving, so it is based on that. So you need to pick as per the problem. So environment, setup, processor, speed, features, and that I will share. Or if you will go through my published article, then I mean some of the environmental factors are there, right? That I will say. Speed is another issue. Okay. And then feature selection, like as I said, like there are like 34. There are 34 features that we selected from the data set. That I will share with you. If you want to, I mean, do kind of research or want to, reciprocate or implement the same work, then definitely my email ID is there. So you just write to me. I'll share you whole thing.
Yes, so I think there are a lot of queries from the participants. So
Yes,
participants, you can in order to have a detailed work, you we will share the contact information of Manoj sir with you, and
yes, yes,
you can
please.
refer his papers for further upgradation of your knowledge. And in any case, in case of any doubt or clarification, we will organize another special session with Manoj sir for
Sure,
all
sir.
of you.
Yeah.
So now over to you, Sanobar ma'am.
Thank you so much, Dr. Manoj. And it was indeed a talk of its own kind, you know. And
Thank you,
Dr.
ma'am.
Sudhanshu is also being thanked here on my behalf for taking up the important task as a moderator. So we're indebted to both of you today. And indeed, it was a session. Honor to
Thank
have
you.
you, sir.
Thank you,
Looking
ma'am, very
forward to
much.
many more of such kind in future, as Dr.
Sure.
Sudhanshu just said.
Yes,
So
ma'am.
I request our moderator, sir, Dr. Sudhanshu, to felicitate our guest for the session. And I request our IT team to display the certificate of appreciation as a small token of love, respect from our end, the small Amity family gratitude attitude. Over to you, Dr. Sudhanshu, sir, please.
So sir, kindly accept our this
Thank,
small token of gratitude as a
thank
certificate
you
of
very much, sir.
acknowledgement,
Thank you. It's my honor.
and we will
Yeah.
share the same on your email ID.
Sure, sure, sir. Sure. Yeah.
Okay.
Thank you very much.
So,
Thank you very much, ma'am.
and
Thank
thank
you,
you for
sir.
joining us and
Okay.
enlightening us. Thank you,
Yes,
sir.
thank you, sir.
Have a good day, sir, from
Have a
our
good day.
end.
Yeah,
Looking
have a
forward
good
to
day,
meet
sir.
you soon.
Soon, yes, same here. Thank you very much.
Dear participants, moving ahead with the session, the next the next keynote speaker for the day is Professor Raghuraj Singh, Dean, Continuing Education and Internal Quality Assurance, Harcourt Butler Technical University, Kanpur, India. Sir, I have the privilege of introducing you for the session to the audience. Sir is working as a prestigious academician, and he has more than 33 years of teaching experience as well as huge amount of research to his contribution. He has successfully discharged administrative responsibilities in the same domain. Sir has worked as director at KNIT Sultanpur, nodal officer IIT Lucknow, director mentor of Rajkiya Engineering College Ambedkar Nagar, nodal officer of Rajkiya Engineering College Bijnor, head of the department, registrar, controller of examination, chief proctor, to name a few. Professor Singh has handled 7 research and consultancy projects funded by AICTE, New Delhi. Sir is member of professional bodies like IETE, IE, ISI, CSI, ACM, ISTE, to name a few. Sir has reviewed and taken tremendous contribution for several research papers as a reviewer. Sir is member of the editorial board of many national, international journals and for conferences and books. He has published more than 170 research papers in national and international journals of repute. Sir has 5 books and several book chapters to his credit and 16 PhD theses under his guidance. So we're honored to have you here with us as our esteemed guest. We invite you and leave the platform open for your experience sharing. Thank you, sir.
Raghuras, sir, you kindly unmute, sir.
Sir, I guess yes,
Yeah.
you need to unmute, sir.
Yes,
Thank
sir,
you so much,
yes, sir. So
ma'am,
you
for
better share your
giving.
PPT from your end. Yes, sir.
Okay, I will share.
Okay, sir. Thank you, sir.
So thank you very much, ma'am, for giving an exhaustive introduction of mine. Before I start my talk, I would like to congratulate the Amity University, Tashkent, for organizing such a wonderful conference on advancement in the computational science, consecutively in a row, third time. And I would also like to convey my thanks to the this keynote session moderators, Professor Sudhanshu Tripathi ji, as well as Professor Sanovar Khan ma'am, for taking pains to invite me, as well as giving me opportunity to share my views and thoughts in this August gathering, which is there in the, on the occasion of this particular conference. So as you...
So we are honored to have you here, sir. We are honored to have your presence. Thank you.
Thank you, ma'am. Thank you. Now let me share my screen. Can you see the presentation?
Sir, your presentation is visible.
Okay, thank you, ma'am. So as you see that the topic of my today's talk in this prestigious conference is optimization of the software reliability allocation problem using genetic algorithms. I have organized this talk in 3 segments. The first segment will be about the introduction of the optimization, that what actually optimization problem is. The second, the introduction about the genetic algorithms, that how the evolutionary approach works for optimization of the problems. And third section will be exclusively devoted to that what is the software reliability allocation problem and how we make optimization of the various reliability of the components of the software so that we are going to achieve the ultimate target reliability for the system which we want to design. So first, if we talk about the optimization, all of us know that optimization is basically the process of obtaining the best results under a given circumstances. So some of the circumstances or some of the situation is given to us, and under that situation, we have to see that how the optimal solution of a given problem can be found out. Again, you can say that in a more elaborative way, that it is the process of finding the conditions that give the maximum or minimum of an objective function. So related with the problem which is given to us, we have to define an objective function, and we have to see as per our requirement that whether the value of this objective function has to be maximized or it has to be minimized. If we mathematically talk about that what optimization problem is, we can say that we need to minimize a function which we are going to represent here as f0x.
Raghunath sir, sorry to disturb me. Could you make this presentation in the full screen mode?
Okay.
Yeah.
Is it visible now in full screen?
Yes, sir. It's okay now. Thank you, sir.
Okay. So you see that the optimization problem can be mathematically defined as that we need to minimize the function which we are representing here by f0x, and the environment which we talked about, or the constraints or the restrictions which we talked about, these are that is represented by another function which is gix less than or equal to bi. So here x is nothing but these will be some of the design variables which will be required to be assigned some of the values so that the value of the function f0 will be optimized, that is, it will be maximized or minimized as per the requirement. And simultaneously, we have to take care of the constraints which are given to us in the form of gix less than or equal to bi. That is, some of the constraints are given to us, those constraints have to be obeyed or those constraints have to be followed. So this is the optimization problem. If we talk about the optimizations, generally we see that the optimization will be based on either the local search methods or the global search methods. In case of the local search methods, the basic idea is just to improve the current solution. So at whatever state we are, we have to make improvement on that particular state. So we will be starting with the starting state and trying to find out that which one is the closest state corresponding to the current solution. And there may be many variations of this. That one of the variation may be that we will not be searching the better solution corresponding to the current state of the problem, but we may search the best possible alternative which might be there. So these kind of variations will always be there. But the problem with the local search methods is that here there is a possibility of sticking into the local maxima. In local maxima, we will say that we will be getting trapped into such a value that which is although locally better, but maybe that if you make further moves, in that case, even better solution might be available to you. So that way, we don't prefer generally these local search methods and try to opt for the global methods. The evolutionary approach is generally based on the global solution or the global search-based solution for the optimization problem. Here, what we do is that we just generate a population of the solutions, then we select the parents and make the reproduction operators, apply the reproduction operators for the crossover or the reproduction of the two parents, so that the offshoot will be created with that. And if the desired condition is met out, in that case, we will be stopping. Otherwise, we will be continuing with generation of children or offshoot all the time until the desired condition is achieved or the desired solution is obtained. So this is the general methodology which we have to adopt in case of evolutionary approaches. We know that evolutionary approaches basically generated from generations to generations. So in every generation, there will be some of the improvements with respect to the previous generation. So in a number of generations, we have to proceed with, and the process has to be continued until the desired solution is obtained. If you see the evolutionary process in more elaborative way, you can see here that we have got some random solutions available over here. Like we have written here solution number 1, solution number 2, and up to solution number 10. So these 10 random solutions are formulating the overall population or the solution space corresponding to the given problem. Then what we do is we select two parents, like here we have selected solution number 3 and solution number 7 as the two parents. And then we are applying the crossover operator. And by making application of the crossover operator, we are generating the offsprings corresponding to the two parents which were selected by applying the crossover operator. Then we are applying the mutation operator on the offsprings so that there is no possibility of getting stuck into the local maxima and obtaining the mutated offsprings corresponding to the process. And then these offsprings are replacing the older elements from the population so that the next generation of the population will be having better elements present into it. So this is the general methodology which is supposed to be followed in case of genetic algorithms. If we see the various concepts related with the genetic algorithm, we say that genetic algorithm is basically a searching technique which is used in computing to find out true or approximate solutions to optimization and search problems. And these are categorized as the global searching techniques. As I said that in the local searching technique, we have the problem of getting stuck into the local maxima. So that's how we are generally following the global searching techniques for these kind of problems. And GAs are evolutionary algorithms. This we have discussed that the solution is generated in different kind of generations. So in every generation which is going to be generated, there will be slight improvements from the previous one. So this process is continued until we are able to obtain the desired solution. There are some of the components of the GA, genetic algorithm. These components are that first we have to represent the potential solutions. That is, we have to create the generation of the solution. So this is generally created in a random way. So initial population is generally created by random process. We say that the tossing of coin may be used for creation of the initial generation. And then an evaluation function has to be defined whose role will be just to find out that what are the values or what are the ratings which are associated with the various solutions which have been generated. And then a collection of genetic operators must be there, particularly selection, crossover, and mutation operators must be there, which will be operating on the selected for selection of the parents, applying the crossover of the parents, generating the offsprings, and then performing the mutation operator on those offsprings so that they can be included into the next generation. And finally, we need to have one of the component which is values for the various parameters. By parameters, I mean that what should be the crossover point, what should be the rate of crossover, similarly, what should be the mutation rate. So those kind of parameters have to be formulated if we have to apply the genetic algorithm approach for optimization of any problem. The selection operator is basically just making selection of the 2 parents out of the total population which is available to us. So this selection is generally made on the basis of that how promising the parents are. So for that purpose, we can make use of the roulette wheel approach, in which the space is, you can see here that the space is allocated on the roulette wheel according to that what is the value of the corresponding parent. So if there are n number of parents, so n spaces, that the total 360 degree space will be divided into n number of subspaces on the basis of that what is the value of the particular element in the generation. So that way, that space which is of larger area will be having more chances to be selected as the parent. So this means that those parents which are having the better values associated with them, or those parents which are of more promising nature, will be having higher chances for getting selection. And if they will be perform with the crossover operator, in that case, there will be always the chances of that they will be generating better offsprings. So that way the population will be, the quality of the population will be increasing. Then we have got the reproduction operators, particularly crossover and mutation. Crossover is that we have to, after making selection of the 2 parents, we have to apply the crossover operator to generate the corresponding children or corresponding offsprings from the parents. So generally what we do is that we select a crossover point in the particular chromosome or particular element of the generation. Suppose this is the point which is the crossover point. So accordingly, the 2 children are generated from the 2 parents. You can see here that if we talk about the first child, this first child has been generated as the first part of the parent number 1 and the second part of the parent number 2. Similarly, the second child has been generated with the first part of the parent number 2 and the second part of the parent number 1. So that way, child 1 and child 2 have been generated by performing the crossover operator. Then we have to perform the mutation operator on the children which have been generated after performing the crossover operator. The basic objective of performing the mutation operator is that we have to avoid sticking into the local maximum. So that way we will be selecting some of the bits in the parent, this children structure, and we will be just flipping those bits. That is, if the bit was 0, in that case we will be making it as 1, And if it was 1, in that case, we will be making it as 0. So that way, there will be lesser and lesser possibility of getting stuck into the local maxima. So here you can see that this bit has been selected as the mutation position. So here it was 1, so it has been made as 0 after mutation. So this way the mutation operator is performed. This way we can see that although we are performing optimization of the problem with the help of GA, but it has certain problems also, or certain issues which are associated with genetic algorithm. Like here you can see that what is an adequate encoding for the problem. So if some problem is given to us, first and foremost requirement will be that how this problem has to be customized according to the framework which is defined in the genetic algorithm. So this problem has to be overcome by defining that whether we are taking a single bit to represent, that is binary sequence to represent the problem, or we are going to select some other kind of system for making representation of the problem, or particularly the various elements or various chromosomes which will be available in the initial population of the solution which has to be provided. Then second issue may be that what should be the size of the initial population. So generally we have to find out the population size, that how many elements or how much size of the solution space has to be provided. So in general, the size of the solution space is taken as 25 to 100. And then the next issue is that what should be the number of best fit chromosomes kept from one generation to the other. So this is also a deciding factor in that what should be the quality of the subsequent generations which will be generated. Likewise, what are the possible crossover and mutation operators which are adopted to the selected encoding? So crossover operator, it is not that only 1 point crossover you can select. There may be the 2 point crossovers also. And likewise, the mutation is not necessarily corresponding to a single bit. It may correspond to multiple bits also. And similarly, what is the rationale for the use of specific crossover and mutation operators? So these are certain issues which are associated with the problem. And if we see the things related with the genetic algorithm, we can find out that GAs require a number of parameters, as we talked about initially, that what is the population size. Generally, we say that the population size should be 25 to 100. And likewise, what should be the crossover rate? The crossover rate is roughly selected as 0.6. Similarly, the mutation is, the purpose of the mutation is that it prevents the GA search to fall into the local optima, but they should not happen too often. So rate should be 1 divided by n, where n is the number of genes which are present into the chromosome. So values of these parameters have to be fixed, and then we have to search for that what should be the termination condition. It is not always the case that every time you will be terminating your algorithm in the successful way. Sometimes it may terminate in the failure also. So we have to fix that what should be the terminating conditions. Like one of the terminating conditions may be that a solution is found that satisfies the minimum criteria which has been laid out. So once the solution has been found out, we can just terminate our algorithm. The second way of termination may be that we can fix the number of generations. Let us say that if we have reached to say 100 generations, we will be ultimately terminating the problem, whether we have found the solution or not. Yet another way of termination may be that how much time we are going to permit for the GA concept or evolutionary approach concept to proceed. And similarly, the highest ranking solutions fitness is reached once the fitness is reached, in that case also we can terminate the solution. So these are the various ways with which we have to proceed with the evolutionary approach which is adopted in the genetic algorithm. Now we come to the third section, which is about the software reliability allocation problem. The software reliability allocation problem is basically arising when we are in the process of development of some software. And that software which is particularly based on the concept of modules or the concept of various components. So whenever we are in the process of designing a software, in that case, what we need to do is that overall software has to be divided into a number of modules or a number of components. And then modules or components have to be put together or integrated together so that the overall objective of the software is going to be achieved. The question is that if we are fixing some reliability constraint with the overall problem, that is the system which we are developing, let us say we have to have the reliability of that overall system as the capital R. Then the question is that what should be the reliability of the various components with which it is going to be constituted. So the target reliability of the capital R is going to be distributed, or it is going to be allocated to its various components. So obviously that what reliability has to be allocated to the various components, it will be dependent on that how well the components are going to perform and what is the pattern of interaction or the way of integration or the methodology of creating the interface among the various modules or the components. So these patterns will be deciding that what should be the component reliability. So reliability allocation problem is nothing but, given a target reliability, our objective is to allocate optimal reliability values to various components with which the software is supposed to be constituted. So mathematically, we can write it like this, that R, capital R, which is the target reliability, it is equal to pi j varying from 1 to n Rj, where Rj is the reliability of the particular component. So this expression is for the various modules or the components if they are connected in a sequential way. So if all the modules are connected in a sequential way, in that case, the overall reliability of the system which we want to constitute will be pi of j varying from 1 to n Rj. But if the transition pattern is different, they are not connected in a sequential way, in that case, the reliability expression will be changing and it will be dependent on that what is the successful criteria for the individual modules with which the software is going to be constituted, as well as what is the transition probability of one module for transferring control into some other module or component. So this way, we will say that the solution, if we try to map this problem into the genetic approach, in that case, the solution space for the SRA problem is nothing but it will be simple n number of values of the reliabilities corresponding to n number of components with which the software is supposed to be constituted. And optimization in this context will be just searching for a reliability order, that what should be these n number of values for individual n modules. And the system reliability, given our objective, will be based on the module reliabilities, that is individual module reliabilities, as well as their transition probabilities, as I said earlier. And the constants here must be that we have to optimize the objective function. What is the objective function? Objective function is nothing but the expression which we will be deriving for expressing the ultimate reliability in terms of the reliability of the various other components. So for this purpose, what we will be doing is that we will be adopting the model in which we will be observing that what is the behavior of the various modules, that how, in what way various modules are going to transfer the control to other modules, and we will be fixing that what will be the reliability expression. So generally you will see that the reliability expression will be of this type, that R1 will be equal to R1T plus R1I multiplied by R1T divided by 1 minus RII. This expression is derived from the Markov model, in which we believe that the behavior of any module will not be depend on the previous conditions of the module. So this type of expression will be derived for the reliability allocation to various modules. And then we will be applying the concept of genetic algorithm to it. How the expression has been derived, that has been elaborated over here, that our ultimate objective is that we have to start from module number 1 and go to module number T. The T refers for the terminal module where the program will be the terminating, or the software which is supposed to be developed, it will be terminating. So we have taken one intermediate state I, and we say that from here the transition sequence will be made from module number 1, which will be reaching to module number I, and then the control may keep on repeating or coming back to the module number I again through some number of transitions which will be made. And finally, from this module I, the transition sequence will be made to reach to the transition, this terminal module T. So this way, by using this concept of the hidden Markov model, we have formulated the previous equation, which will be used as the objective function. For our purposes, the study which we have carried out, we have taken a very complex system for calculation of the reliability expression. We have assumed that purely the modules are not in sequential nature. Also, they are not switching kind of modules, but they may be in hybrid mode, that they can transfer the control in a sequential way, as well as they can transfer the control at any time to any other module in a random sequence. So this is the module which is given to us, the software structure which is given to us, in which the control will be transferred from one module to the other. And using the hidden Markov model, we have developed the expression of the reliability values for this type of module in this way. I don't need to explain it. You just assume that this type of expression has been developed for a generalized kind of software structure, which will be consisting of all kind of modules present into which will be transferring the control in sequential way as well as in the parallel way or in integrated way. Then we will be customizing our problem according to the genetic algorithm. So what has to be done is that encode the problem in the binary sequences, that is, the various chromosomes have to be constituted in the generation, and these chromosomes will be nothing but they will be having n number of components into it, assuming that there are n number of modules in the software which has to be constituted. So n number of components will be there, and every component will be representing that what is the individual reliability value of the particular module. So what will be the size of an individual component, or what will be the overall size of the chromosome? It will be decided by that what is the precision of the reliability value which we are going to assign. So if precision is, let us say, k bits, in that case 10 to the power k may be the maximum possibility. So we have to take log at the base 2 of 10 raised to the power k. So that should be multiplied by n. It will be giving you the size of the total chromosome. So n is the number of components which are present into one chromosome, and log 10 raised to the power k base 2 is the size of every component. So that way, the size of one chromosome is coming out to be as n multiplied by log 2 10 raised to the power k. Then we have to decide that what should be the initial population. As I said, that initial population is generally taken between 25 to 100. So you can select any value between 25 and 100 for this purpose. Evaluation function in this case is simple reliability expression which we have developed. So we say that eval is the evaluation function which is evaluating the overall reliability R corresponding to R1, R2, R3, so on up to Rn, which are the individual reliability values. Then we apply the concept of genetic algorithms. We say that generate the initial population with a specified number of strings. Each string will be nothing but it will be giving us the individual values of the reliabilities of various components, and then select two candidates as the parents, apply the crossover operator, compute the fitness value of the offsprings which will be generated, and if the number of offspring is less than the population size, in that case go to step 2. Otherwise we have to continue and then replace the parents with the offsprings, retaining the best solution for the previous generation. So this process has to be all the time repeated, and that way we will be able to find out the optimal solution through a genetic approach. We, in our experimentation, we have taken this particular example, and for this we have calculated the reliability expression as this one, and finally applied various parameters on the genetic algorithm, that is using target reliability of the system as 0.934, population size as 25, string size as 30 bits, mutation rate as 0.3, mutation position as the 11th bit, and the single point crossover at the 15th bit. With these parameters, we have calculated that the three modules which are present, they need to have the reliability of 0.9998, 0.9989, and 0.9932. So corresponding to this target reliability value, the reliability values of the module number 1, 2, 3 should be these according to the optimal allocation which has been given by the genetic algorithm approach. So with this, I conclude my talk, and I hope that the participants and delegates must have been benefited with whatever I have delivered this in this short interval of time, because the time allocated was too less, so I could deliver this content relatively in a faster way. So I thank you all for patient listening.
Right.
And if there are any questions, we can always welcome.
So we're really grateful. And of course, it is always a pleasure to see so much of eagerness and excitement in experts like you to share more and more, that you're finding the time less. We definitely will invite you at further platforms in times ahead. It'll be our pleasure. I hereby invite our moderator for the session, Dr. Sudhanshu, to please take over the platform and carry forward the question and answer round with the audience and the expert. Thank you.
The students and all the participants are requested to put their questions in the chat box. Even our colleagues have also shared the questions with me to ask, because as of all of us know that for the optimization, to deal with the optimization problem, evaluationary algorithms are playing a great role. So there is one question, sir, from our respected colleague, that can you explain the difference between this genotype and phenotypes in the evolutionary algorithms?
Actually, it all depends on that how you are framing the chromosome. So chromosome is giving you the pattern according to which the individual solution has to be constituted. Then one particular section which is corresponding to one of the parameter which has to be optimized. If you see the structure of overall structure of that parameter, it is called as genotype. And whatever values are there, these will be corresponding to genes. And phenotype is representing a combination of various genes together, so that they will be representing a group. And this will be called as phenotype.
Okay, okay, okay. So I hope he has got his answer. And sir, generally in the optimization problem, sometimes there is a word that comes like a black box. So generally, how we should consider that black box in general terminology
Sir,
related to the evaluation algorithms.
sir, I could not listen your question.
Sir, when we are doing the optimization, so there is a term that comes black box. So how that black box term is related with the evolutionary algorithm? Could you enlighten that one?
Black box, I am not clear with that what actually it is. In general, black box is that where you are not giving the internal details, only focusing on the functionality.
Yeah, yeah, yeah. So I think that is related. Yeah, I think that is in that context only.
Yeah. So black box is where you are not giving the internal functionality, internal details of the things, and just focusing on that what is the actual functionality which you want to achieve.
Yes, yes. So I think, sir, that's all from the. Is there any? Let me check, sir. That is there any question in the chat box from the participants or students? Okay. So that's all from our side. So Sanovar ma'am, it's over to you. Kindly unmute, ma'am. Sanovar ma'am, kindly unmute.
Thank you, sir, and thank you, Dr. Raguraj. We carry forward this talk by felicitation of our respected guest. And we request Dr. Sudhanshu to please do the honors. We have a small token of appreciation from our end, sir, in the form of a certificate for you. I request the IT team to display the certificate for our guest. And here it is, sir, with all affection from our end. Thank you so much.
Thank you so much, ma'am, and Sudhanshu sir. I always appreciate these kind of efforts, and I am always open. I have long association with MIT University, and whenever you will be calling, I will be always there.
So pleasure is all ours. Thank you so much, sir.
It's an honor for us that you are with us, sir, from your busy schedule, and I know that how much busy you are. And this is a kind of a small token of love and appreciation from our side, and the same I will send to you on your mail also. So
Sure, sir. It's my pleasure. Thank you. Thank you
thank
so
you, sir.
much.
And I have also sent a request to you to join our valedictory function. So if the time will permit you, kindly join that also.
Sure, sure. If I find time, definitely I will try to
Sure,
join.
sure, sure. So, so no, IT team kindly
Yes.
check whether our next speaker has joined or not, because there is some technical glitch at his end.
Sir, Mr. Abubakar, he is in the he is not in the meeting right now.
Dr. Abu Bakr, because okay.
So Dr. Abu Bakr, I guess, is yet to join the meeting. He's not
No,
there with
no,
us.
no. Actually, he has. There is some technical glitch at his end. Every
I
time he
see,
is
sir.
joining and getting disconnected, and our IT team is trying their best effort to get him in. So well, dear participants, we will wait for a few minutes more to let.
Sure, sir.
Yeah. I'm trying to get connected with the next speaker. There is some technical glitch at his end. Meanwhile, we will wait for 5 minutes more. Sonovar ma'am.
Yes, I'm here with you.
Okay. So let's wait for 5 minutes more. Otherwise, we will
Yes,
conclude the session.
yes,
Okay.
yes. Yes, sir, I'm
Uh,
here with
I'm
you.
trying to
As you
get
say,
him
sir.
connected. Okay.
Sure, sir. Sure.
I think our last speaker of this session is not able to join because of some technical glitch. So I request the moderator of the session, Dr. Sonovar Khan, to conclude the session.
Thank you so much, Dr. Sudhanshu, and I thank all the guests who joined us today. Heartiest, gratitude from the Amity family, and we look forward to further collaborations at prestigious occasions of such sort. As academicians, we always look forward to gatherings of such kind. Thank you, Dr. Sudhanshu, for giving me a chance to be a part of the event. I'm highly grateful to the entire team, and I take pride in being a part of it. Thank you. I
Okay,
request the
so
IT team to close the
I,
session after
yeah,
Dr. Sudhanshu announces whatever he has.
okay. So IT team, please IT team is requested to close the session and the
Okay.
meeting, please.
Thank you, sir. Thank you, IT team.